Hello guys, we want to proceed to question 3 and we want to see how we can get the products from the following chemical reactions. In fact, question 3 is saying what products will be obtained when acetophenone reacts under each of the following conditions. So the conditions have been put there. We are having the reagents. So what we'll do is this. We'll give you the the end products of these chemical reactions, and then we'll try to come up with a few reaction mechanisms so that you can have a better understanding of what we're going to do today. So look forward to a video where I'll put up the chemical reaction mechanisms of each and every reaction in this question. So we'll start with the first question.
Okay. Part A, you have acetophenone react with nitric oxide and sulfuric oxide, uh, sulfuric acid. So what is going to happen is there will be a reaction between nitric oxide and sulfuric oxide. So the reaction is this. Mm, Before we even go to the acetophenone, this is A. Sorry, pen. Um, it's the acid H um, H O S sulfuric acid reacting with nitric oxide or nitric acid, which is um, H O N double bond there, then a single bond negative there. Okay, so it is this nitric acid that is going to get a proton from the sulfuric acid, like that. So this is the mechanism we're going to have. Okay, then we're going to end up with the H bonded to this, the hydrogen we got from the sulfuric acid, and that oxygen 1, 2, 3, 4, 5, 6. Okay, so now the water here is a good Riven group, so this one will go. So first the oxygen here, down here, the bond here will reform, kicking off the water there. So we are going to have something like this, a double bond here, and the reformed new double bond there, and then this lone pairs, and this nitrogen becomes a positively charged and electrophilic substance plus water. The water was lost. So this is what we have. Having this nitrogen dioxide we have formed, the nitrogen dioxide we have formed, uh, will come now to the structure acetophenone. Okay, right. So the nitrogen dioxide said this is an electrophile. So here it the double bond here will come and touch there to a nitrogen. We are going to have a ring structure which will looking like this now. Okay, we have that. So number one, we have broken the bonds there and added a nitrogen. We've broken the bonds there and added an N. This means that this will go there. So in short, this is just nitrogen dioxide. Nitrogen dioxide. Okay. Um, right. Okay. So nitrogen dioxide. Having this, it will resonate. Resonance will start to happen here. You're going to form a resonance structures. So resonance structures, um, which can be okay, form resonance structures here, where the double bond can alternate inside this. So we can either have it here and here, having the nitrogen here, or structure another resonance structure. Okay, we can have it, we can either have the double bond here and here. Okay, so these are just resonance structures. Okay, so we'll take the first one as showing the electron density. Electron density. All right, then the NO2 there plus a hydrogen. We have a hydrogen here. Okay, and this. So this ring has lost its aromaticity. So unless we get rid of this hydrogen, then we can retain the aromaticity of this ring. So remember, at first we deprotonated the acid, sulfuric acid. So now we are remaining with this structure of sulfuric acid. This is what we are remaining with, negative. So this will come under, gets the proton there, and we are going to form a double bond there. Hence our structure will be formed as this. Okay, and the aromaticity is back in the ring. Yes, so this is the product. For those who are who want to write it in just one word, you can just say, this is my acetophenone, without showing the mechanism. Yeah, without showing the mechanism, reacting it with nitric acid and sulfuric acid. Just add the nitrogen here without the mechanism. If they ever ask you to write without showing the mechanism, but that's the mechanism for this, for you to form this. Okay, question B. Acetophenone now reacts with acetophenone reacts now with okay, so they said now you're reacting with C6H5 NH NH2 in presence of an acid. So use an acid, any acid we want. We can even use this. So we'll show the first step. This structure can even be written as it's just a benzene ring, a phenol. A phenol. It's a phenol. This, yeah. So you have this. This is the structure, same as this one. These are same. Okay, so the first step is since we have an acid, it will be protonation. We'll protonate the the ketone there on the acetylphenol there. We'll protonate, we get the hydrogen from there. Then we are going to have the structure which looks like this. The double bond is not yet broken, it's still there. Okay, then the the acid uh, right, this structure comes in. Okay, so these lone pairs of electron will come under attack there, hence opening the bond there. Hence we have the structure which will look like this. This is the mechanism for this. The bond there is broken, we have an alcohol there. Then here there is a nitrogen bonded to two hydrogens, bonded to two hydrogens, and another nitrogen there, and our phenol there, right? Then this nitrogen becomes a positive recharged. Then the oxygen which is here, it will come and deprotonates the hydrogen there. Okay, um, so we are going to form water there. Going to form going to form water here. Water is formed. Then we have nitrogen with lone pair after donating that proton, the hydrogen, and the phenol there. Okay, then this oxygen here, the water becomes a good living group, so it lives here, meaning with the protons there. Or some people will say okay, the acid we used at first, the acid we used, it needs to regain its acidity. Okay, remains with water. This comes to get the hydrogen, then here the the double bond is formed there, which is this the hydrogen there. We get the hydrogen, then the hydrogen falls, the electron kicks off this one, and we remain with a double bond there. Same thing, or you can say water goes, then the water comes to get this hydrogen and forms a bond there. Hence we have a hydrozone. This structure is called a hydrozone. Here we have this, the double bond now goes to the nitrogen here, then the nitrogen is bonded to this. Okay, is this ring correct? Okay, right, double bond, double bond, double bond. So this is the hydrozone we are able to make. Or in short, if you want to make this one short, you can just say if I have this acetylphenol which contains a ketone, reacting it with this guy. Okay, reacting it with this, I should get, always it's just to add, remove the oxygen here and add it to the nitrogen with a double bond falling on the nitrogen. Remove this oxygen, then you add this hydrogen here. This is a shortcut, but the mechanism is explained on top. Okay, so if we are to do that, this one goes up, this one is the one which is coming here up, then we are going to add the double bond there, a nitrogen, and then hydrogen, remove it, yeah, so that this one becomes as a lone pair there. So that's it for part B. This is how you form the hydrogen. Okay, um, yeah, so if here we had another ring structure, like where I have put a hydrogen, you put the ring structure which was there, you put the ring, your ring structure. So this is just a shortcut, yeah, to those who need a shortcut. Okay, then move on to C. So the that C is not looking good. Okay, the acetophenone now react with reaction we did H2C there, lone pair, then phosphorus with a positive, then this is what is called also a phenol, C6H53. This is a phenol. So this, we can show the mechanism by saying, okay, we'll come back to draw the products there. So this is just the mechanism. Okay, um, the first thing what happens is the I'll draw this one. I'll show you H2 double bond there, phosphorus, then this one I'll be using it as pH3 as a phenol. So this lone pairs of electron comes here to attack, then it breaks the bonds to the oxygen, then you have a structure looking like this. Okay, we have broken the bonds there, which is the oxygen, then we have added a carbon there, then the carbon is here, which is having two hydrogens, right? The hydrogen there and another hydrogen. This carbon is bonded to the phosphorus there, and the phosphorus is having the pH 3. So this is negative recharged, the oxygen, then this is positive recharged. So they are going to attract each other there, and okay, try. We're going to form a structure looking like this. Um, there, down, oxygen. Now oxygen will go to phosphorus, which is having the pH 3 there. Then this phosphorus is attached to the carbon having the two hydrogens, and this carbon is attached to this carbon. Yes, something looking like a box. Yeah, so in this ring which is formed, there will be breakage of bonds. So this bond comes to break here, this one breaks there, hence we are going to form this structure. We are going to draw the way we are seeing it. The bond is the one which is here. Maybe use a different color. Here is a bond which is here. Then here there is folding of bonds which came here. So there is a double bond there. We formed a double bond. And we even had this. this will be there. Then this, after a double bond, there we have a carbon with two hydrogens. Hence the structure was formed for this, plus the pH3, which is bonded, double bonded to an oxygen. So the structure which was formed is this one. So now we can write there our structure so that we see the short.
Sodium borohydrate in the presence of a base. Okay, so sodium borohydride, to show the product will be just this. Product will be, will reduce, it will just reduce the ketone to a secondary alcohol, like that. The mechanism can be okay. Then now we have this. Yeah, a hydrogen there. Okay, then we are going to have a base. A base comes to attack, of which it is this. So this is a negatively charged, comes to attack there. A nucleophile attacks an electrophile. Then we have the structure, hence breaking the bond to the oxygen there. Yeah, sorry about the allos. Then we are going to add an oxygen with CH3 there. Yes, then this had a hydrogen, then the boron can come and take up that hydrogen back.
by just deprotonating, or we can use water if we don't want to make another tetraboride. Yeah.